Picture this. In a single rice paddy field in Asia, farmers are harvesting not one crop but two. From the same flooded field, they pull in thousands of pounds of rice grain and tens of thousands of live fish. This is not science fiction. This is integrated rice fish farming, one of the oldest and most sustainable forms of agriculture technology still thriving in the modern world. In countries like China, Vietnam, and Bangladesh, more than 2 million tons of fish are raised annually in rice paddies, feeding millions of people while improving soil health and reducing the need for chemical fertilizers and pesticides. But how does this ancient system actually work at an industrial scale? How do farmers manage to grow rice and raise fish in the same water without one destroying the other? And how are millions of these rice fish processed, packaged, and sent to markets around the world? Welcome to AgriCraft, where we take you behind the scenes of the most fascinating agricultural systems on the planet. Today, we are diving deep into the flooded fields of integrated aquaculture to show you exactly how millions of rice fish are grown, harvested, and brought to your table. All will be revealed in this video. Integrated rice fish farming is not a new invention. In fact, it dates back more than 2,000 years to ancient China, where farmers discovered that stocking fish in their rice paddies created a win-win situation. The fish ate pests like insects and snails that damaged rice plants. Their waste fertilized the soil naturally, and the rice plants provided shade and shelter for the fish. It was a closed-loop system long before sustainability became a buzzword in modern agriculture. Today, this practice has exploded across Southeast Asia, particularly in China, which produces more than 1.5 million tons of rice fish every year. Vietnam, Thailand, Indonesia, and Bangladesh are also major players, and the system is slowly gaining traction in parts of Africa and even experimental farms in the United States. In fact, farmers in California and Arkansas have begun testing integrated rice fish systems as a way to diversify income and improve environmental outcomes on their land. The most common species used in rice fish farming are carp, tilapia, and catfish. These fish are hardy, fast-growing, and can tolerate the fluctuating water levels and temperatures found in rice paddies. In China alone, more than 3 million hectares of rice fields are used for integrated aquaculture. That is an area roughly the size of Belgium. And it is not just about tradition. Modern rice fish farming is a highly efficient form of food production that can yield up to 30% more income per hectare than rice farming alone, making it an attractive option for smallholder farmers and agribusiness professionals looking to maximize land use. But here is the shocking part. Despite producing millions of tons of fish every year, integrated rice fish systems use almost no antibiotics, growth hormones, or artificial feeds. The fish thrive on the natural ecosystem of the paddy, eating algae, plankton, insects, and leftover rice bran. This makes rice fish one of the cleanest and most environmentally friendly protein sources in the world. The process of growing millions of rice fish begins months before the first fish enters the water. It starts with the careful preparation of the rice paddy itself. Farmers must create an environment that supports both rice plants and fish simultaneously, which requires specific modifications to traditional rice farming methods. First, the field is leveled and plowed to prepare the soil. Then, shallow trenches or deeper refuge ponds are dug along the edges or in the center of the field. These trenches serve as safe zones for the fish when water levels drop, or when rice farming activities like pesticide application or draining occur. The trenches are typically 1 to 2 meters deep and can hold hundreds of fish per square meter during peak stocking periods. Once the field is prepared, rice seedlings are transplanted. Farmers usually choose rice varieties that grow tall and strong, providing ample shade and root structure for the fish below. Jasmine rice, sticky rice, and high-yield hybrid varieties are commonly used. The seedlings are planted in rows with slightly wider spacing than in conventional rice fields to allow more sunlight to reach the water surface, promoting the growth of algae and plankton that will feed the fish. About 2 to 4 weeks after transplanting the rice, the fish are introduced. Timing is critical. If fish are added too early, they may uproot fragile seedlings. If added too late, they miss the window to establish themselves in the ecosystem. Fingerlings, or juvenile fish, are sourced from hatcheries or breeding ponds. These fingerlings are usually 5 to 10 centimeters long and weigh between 10 and 20 grams. In a typical 1-hectare rice paddy, farmers may stock anywhere from 5,000 to 15,000 fish, depending on the species and the depth of the water. Carp species like common carp, grass carp, and silver carp are the most popular choices. Tilapia is also widely used, especially in warmer climates, because it reproduces quickly and grows rapidly. Catfish, particularly the Asian walking catfish, is favored in regions with lower water quality because of its ability to breathe air and survive in oxygen-poor environments. The fish are fed minimally, if at all. Most of their diet comes from the natural food web within the rice paddy. They eat insects, larvae, snails, worms, and plant matter. Some farmers supplement with rice bran, broken rice grains, or vegetable scraps, but the goal is to let the ecosystem do the work. This natural diet keeps costs low and ensures the fish remain chemical-free, which is a major selling point in organic and sustainable food markets. Water management is the key to success in integrated rice fish farming. The water level must be maintained at around 10 to 20 centimeters for most of the growing season to support both rice roots and fish health. During heavy rains, farmers open gates to release excess water and prevent flooding. During dry spells, they pump in fresh water from nearby rivers, reservoirs, or irrigation channels. Oxygen levels are closely monitored, especially in the early morning when dissolved oxygen is lowest. If oxygen drops too low, fish can suffocate, leading to major losses. Farmers also avoid using chemical pesticides and herbicides once fish are introduced. Instead, they rely on the fish themselves to control pests. The fish eat mosquito larvae, reducing malaria risk in rural communities. They consume golden apple snails, a notorious pest that damages rice plants. And their constant movement in the water stirs up sediment and prevents the growth of harmful algae. This natural pest control reduces the need for chemical inputs, which benefits both the environment and the health of the fish. After 3 to 6 months, both the rice and the fish are ready for harvest. The timing depends on the rice variety and the target size of the fish. Most farmers aim to harvest fish that weigh between 100 and 300 grams, which is the ideal market size for fresh sale or processing. The harvest process begins with draining the rice paddy. Slowly, over the course of several days, water is released through gates and canals. As the water level drops, the fish instinctively move toward the deeper refuge trenches and ponds. This behavior makes it easy for farmers to concentrate the fish in one area for capture. Once the water is low enough, farmers wade into the trenches with nets, baskets, and buckets. In larger operations, mechanical pumps and seine nets are used to corral the fish into collection points. The fish are scooped out by hand or with dip nets and transferred into large plastic bins or mesh cages filled with clean water. This is done quickly to minimize stress and prevent injury, which could reduce the quality of the meat. On small family farms, the harvest is a community event. Neighbors and relatives gather to help catch the fish, and the work is often accompanied by food, music, and celebration. On larger commercial farms, teams of trained workers use standardized harvesting methods to ensure efficiency and maintain hygiene standards. Fish are sorted by size and species right in the field. Undersized fish are often returned to the ponds to grow for another cycle, while market-ready fish are loaded into aerated transport tanks. Meanwhile, the rice is harvested separately. Farmers cut the rice stalks by hand with sickles or use small mechanical reapers that can navigate the soft, muddy ground. The rice is bundled, dried, and threshed to separate the grains from the stalks. The rice straw is often used as animal feed or composted back into the soil. Some farms even use the straw to create biogas, adding another layer of sustainability to the system. Transportation of the live fish to processing plants or markets must happen quickly. Fish are highly perishable, and delays can lead to spoilage and economic loss. In rural areas, fish are often transported in open trucks with water tanks and portable aerators to keep the fish alive during transit. In more developed regions, refrigerated trucks with temperature control systems are used to maintain freshness. The goal is to get the fish from the paddy to the processing plant or market within 6 to 12 hours. Once the fish arrive at the processing plant, the real transformation begins. Modern fish processing facilities are designed to handle millions of fish per year with strict attention to hygiene standards, food safety, and efficiency. The first step is unloading. Fish are transferred from transport tanks into large holding tanks at the plant. These tanks are equipped with filtration systems and aerators to keep the fish alive and healthy until processing begins. Before processing, the fish undergo a quality inspection. Trained inspectors examine the fish for signs of disease, injury, or contamination. Any fish that do not meet quality standards are removed and sent for secondary uses like fish meal or fertilizer production. The healthy fish move forward on conveyor belts into the cleaning and preparation area. The fish are first stunned using either electrical stunning or ice water immersion to render them unconscious. This step is considered humane and also makes handling easier for workers. After stunning, the fish are washed in large rotating drums filled with cold, chlorinated water to remove dirt, slime, and bacteria from their skin. Some plants use ozone-treated water instead of chlorine for a more environmentally friendly sterilization process. Next comes the gutting and scaling stage. In smaller facilities, this is done by hand with sharp knives and scrapers. Workers make precise cuts to remove the internal organs while preserving the maximum amount of usable meat. In larger industrial plants, automated machines do most of this work. Mechanical gutting machines use rotating blades and high-pressure water jets to clean the fish in seconds. Scales are removed using abrasive rollers or high-pressure water sprays. The fish are then rinsed again to remove any remaining debris. After gutting and scaling, the fish are sorted by size and quality. Some fish are sold whole, while others are filleted. Filleting machines use laser-guided blades to remove bones and cut the fish into uniform portions. These machines can process up to 60 fish per minute, dramatically increasing efficiency compared to manual filleting. The fillets are inspected again for bones, skin fragments, and defects before moving to the next stage. For fish destined for export or long-term storage, additional processing steps are required. The fish or fillets are placed into blast freezers, where temperatures drop to -40 degrees Celsius within minutes. This rapid freezing locks in freshness and prevents the formation of large ice crystals that can damage the texture of the meat. Frozen fish are then glazed with a thin layer of ice by briefly dipping them in cold water. This glaze protects the fish from freezer burn during storage and shipping. Quality control is continuous throughout the processing stage. Samples are regularly tested for bacterial contamination, heavy metals, and chemical residues. Processing plants that export fish to international markets must comply with strict food safety regulations, including HACCP, which stands for Hazard Analysis and Critical Control Points, and ISO standards. Traceability is also critical. Each batch of fish is labeled with information about the farm of origin, harvest date, and processing date, allowing buyers to trace the product back to its source. Byproducts from the processing stage are not wasted. Fish heads, bones, and viscera are collected and sent to rendering plants, where they are processed into fish meal and fish oil. Fish meal is a high-protein ingredient used in animal feed, particularly for poultry, pigs, and farmed fish. Fish oil is rich in omega-3 fatty acids and is used in dietary supplements and aquaculture feeds. Even fish scales are valuable. They are processed into collagen, which is used in cosmetics and biomedical products. After processing, the fish move to the packaging area, where automated systems take over. Whole fish and fillets are weighed and portioned using digital scales and mechanical separators. For retail packaging, fish are placed into vacuum-sealed plastic bags or foam trays covered with plastic wrap. Vacuum sealing removes air from the package, extending shelf life and preventing oxidation that can cause off flavors. For bulk packaging, fish are packed into large boxes lined with plastic or wax-coated cardboard. Each box can hold 20 to 50 kilograms of fish, depending on the product. Frozen fish are stacked on pallets and wrapped in plastic film to keep them secure during transport. Every package is labeled with product information, weight, expiration date, and a barcode for inventory tracking. Cold storage is essential for maintaining the quality of fresh and frozen fish. Processing plants have large cold rooms where temperatures are kept at -18 to -25 degrees Celsius for frozen products and 0 to 4 degrees Celsius for fresh products. These cold rooms can store hundreds of tons of fish at a time, allowing plants to manage supply and demand fluctuations. Distribution begins once orders are received from wholesalers, retailers, or export buyers. Refrigerated trucks, known as reefer trucks, transport the fish to distribution centers, supermarkets, restaurants, and ports. For international shipments, fish are loaded into refrigerated shipping containers and sent by sea or air freight. Asian rice fish are exported to markets in Europe, North America, the Middle East, and other parts of Asia. Countries like Japan, South Korea, and the United States are major importers of processed rice fish, particularly tilapia and carp. Logistics companies use advanced tracking systems to monitor the location and temperature of shipments in real time. If a container experiences a temperature deviation, alerts are sent immediately, so corrective action can be taken. This level of temperature control ensures that fish arrive at their destination in perfect condition, whether they are traveling across a city or across an ocean. The benefits of integrated rice fish farming extend far beyond food production. This system is a model of sustainability and resource efficiency. By combining rice cultivation with aquaculture, farmers can produce more food per hectare without increasing water use, chemical inputs, or labor. The fish provide natural fertilizer, reducing the need for synthetic fertilizers by up to 30%. They also control pests, reducing pesticide use by 50 to 70%. And because the system mimics natural wetland ecosystems, it supports biodiversity and improves water quality. Rice fish are also incredibly versatile in the kitchen. In Asian cuisine, carp and tilapia are used in soups, stir-fries, curries, and grilled dishes. In China, whole carp is steamed with ginger and soy sauce and served during festivals and celebrations. In Vietnam, fish from rice paddies are often cooked in clay pots with caramelized sugar, fish sauce, and black pepper. In the United States, tilapia fillets from integrated farming systems are gaining popularity as a mild, affordable, and sustainable seafood option. Nutritionally, rice fish are an excellent source of high-quality protein, omega-3 fatty acids, vitamins, and minerals. A 100-gram serving of cooked tilapia contains about 26 grams of protein and only 3 grams of fat, making it a lean and healthy choice. The fish are also low in mercury compared to larger predatory fish, which makes them safe for regular consumption. The environmental impact of integrated rice fish farming is overwhelmingly positive. Studies show that rice fish systems produce 30 to 50% lower greenhouse gas emissions compared to conventional rice farming. This is because the fish consume methane-producing organic matter in the water, reducing methane emissions from the soil. The system also reduces nutrient runoff into rivers and lakes, protecting aquatic ecosystems from pollution. And because the fish are raised without antibiotics or hormones, there is no risk of antibiotic resistance or chemical contamination in the food chain. From ancient rice paddies in China to modern processing plants serving global markets, the journey of rice fish is a testament to the power of integrated agriculture. What begins as a simple fingerling in a flooded field becomes part of a sustainable food system that feeds millions, supports rural livelihoods, and protects the environment. Through careful farming, efficient harvesting, advanced industrial processing, and global distribution networks, millions of rice fish are grown and delivered to tables around the world every single year. This is the remarkable story of how tradition meets innovation, how nature and technology work together, and how smart farming can produce more food with less impact. If you found this deep dive into integrated rice fish farming as fascinating as we did, make sure to hit that like button. Subscribe to AgriCraft for more incredible agriculture documentaries, and drop a comment below telling us what farming system or food production process you would like us to explore next. Thank you for watching, and we will see you in the next video.